I'm very well.
Good evening, ladies and gentlemen, members and guests. It's my pleasure to introduce the speaker tonight, who is an expert on offshore wind farms and is in fact responsible for a lot of the ones in the North Sea and the Thames Array, and is here to give us a talk about the effects on sailors, and I'm sure you'll have lots of questions later about that. We are recording tonight for live streaming on the YouTube platform, so please keep the background noise to as low as possible, and questions I think Sean would like to take afterwards, if that's all right. Over to you, Sean Chennery.
Good evening, everybody. As introduced, my name's Sean Chennery. I lead a team for RWE, so Fleet Servicing Team. That's a team that travels around multiple wind farms via a large boat, and I service them wind farms. When Ian asked me to present here, so Ian had seen me at a previous one, I was actually the general manager at Galliford, but since then I've changed jobs. But for the purpose of today, I'm still the general manager at Galliford Wind Farm. And I've been there for 6 years. My background is engineering background, so I did a time-served apprenticeship at Sizewell A Power Station on the East Coast. So I've worked in nuclear, gas, wind, and I now work for RWE, which is one of the world leading offshore wind installers, particularly in the UK and continental Europe. We develop, build, operate, and eventually will decommission offshore wind farms. So today I'm going to talk you through a bit about offshore wind farms, what they are, why they're there. Hoping that will spark lots of questions as we go through. And I'll try and address some of the issues that previous groups have brought up with regards to navigation. So windmills, you mentioned windmills. I don't like to call them windmills. They make flour, I make power. So they've existed for a long time. But we, basically, the modern ones are set at sea, onshore as well. We don't currently do onshore in my team, but we've got onshore wind farms as well, all connected to the national grid. I was talking to one of your colleagues earlier. Historically, the national grid was set up with a spine down the UK, where most of the big coal-fired power stations sat, where the coal was, sat in the Midlands and connected to the national grid. They've all shut, apart from a few that are now burning biomass. Now we're connecting everything on the outside, so coming from the North Sea and the Irish Sea, connecting to the outside, which has caused a bit of a headache for the national grid. So not only are we different, we're building our wind farms offshore, they've now got to change their network to facilitate power coming in from the extremities rather than the central spine. Half the generation, renewables is a third in the UK at the moment. This was last year at this presentation, it's now more than that, so more than a third of our generation that we use comes from renewables, and half of that is from offshore wind. And that part is growing rapidly. There's new, you'll hear in the news today, another wind farm come on, another one, it's growing rapidly. The first commercial offshore wind farm for RWE was in North Wales, so that was built in 2004. So you can see that's the very first one. Where we've come now, how many wind farms we've got. This industry has rapidly grown in the last 10 to 15 years. Just a bit of stats. So this is 2022. The next page is 23. But UK was the largest source of renewable energy in the UK was offshore wind. We broke records. This was a particular day, and you can see we were in 2022. We were already 26% of the UK generation, and coal had almost gone. And the highest is still gas in the UK. So the biggest generation in the UK is still coming from natural gas. We go to our wind farm statistics here. So we're 353 megawatts from Galliford Wind Farm. If we had a gas-fired power station producing that power, our wind farm saves 3.5 tons of CO2 every day by displacing a gas-fired power station. So you can see that we're helping to clean up the environment. This is now 2023, so go forward a year. Offshore wind, so gas is still about a third, so it went from 38 to 30%. Offshore wind is now 33%. So in 1 year, we've increased by about 10% in the UK of our generation from offshore wind. And we're expecting that's a year-on-year 10% every year. By 2030, we should have 50 gigawatts of installed capacity. What's just a number, isn't it? The UK uses about 40 gigawatts of power every day. So installed capacity, by 2030, we should be able to power the whole of the UK. Of course, wind doesn't blow every day. But it's a massive step forward to be able to have enough installed capacity to produce all of our power in the UK by offshore wind by 2030. A little bit about Gallup Wind Farm. So we are 27 kilometres offshore. Around 380,000 homes are powered by just that one wind farm. We've got 56 turbines out there, so 56 turbines can power around 400,000 homes on any given day should the wind blow. We've got 2 export cables, so 2 cables connect all of those turbines together, and they come ashore near Sizewell. They connect to the national grid near Sizewell, and then that is then pumped into the UK national grid system. The water depths out there, so at the shallowest point it's 27 metres, and the deepest point 36. Go back. Each one of these stands on a monopile foundation. So the yellow bit, basically the bottom bit, goes in the seabed, 30 metres down to the seabed, and then around 30 to 40 metres hammered into the seabed. Each one of those foundations is about 7 metres in diameter, steel, and just basically a vessel comes along, lines it up, whacks it in the sea, and then this turbine is built on top of it.
Concrete as well?
No, these are all steel. So there is concrete foundations up there. So London Array, which is out the water here, they use concrete foundations as well, but these are all steel. And the later design turbines that are now being built on the Dogger Bank and various different places, they are 15 metres in diameter. Water depths, typically we're up to about maximum of 50 metres at the moment. Yeah. Much beyond 50 metres, we have to go floating foundations. I'm not an expert on floating foundations, but we are now working on projects not in Scotland because we didn't win any of those, in continental Europe and in America. Our Gulf of Mexico project we're working on now is over 150 metres water depth. So basically it's either concrete or steel structure that sits under the water, concrete floats, and then chained down to the seabed. So this thing is basically tethered to the seabed by long chains. But Galloper is what we call fixed bottom, and that is a solid foundation that's hammered into the seabed. Before we install it, what we do is we find the location of where we want to put the turbine, we dump a load of rock on the seabed, and then we hammer the foundation through the middle of the rock. The reason the rock's there is to stop scallop. So if we're built on London clay and sand at Galloper, if we didn't put the rock down, within 5 years the sand would erode the foundation and we'd be replacing turbines. So basically we go along.
Life.
Sorry?
A 5-year life is not long.
No, we've got 25-year life on it. So basically dump rock on the seabed, hammer the foundation through the middle, and then build the turbine on the top. Like I say, we are 56 turbines, 353 megawatts, and it produces 6.3 megawatts at 11 meters per second. So the optimal speed, where we've got maximum generation, is 11 meters per second. Each turbine will run all the way down from 3 all the way to 27 meters per second. Somebody asked me earlier on, 27 meters per second is about 52 knots. So it runs all the way up to 28. What happens at 28 is the turbine, I'm a turbine boy, so the blades pitch, so they pitch at, so they're not catching the wind, and they turn themselves at the wind. And they do that automatically, so they've got an odometer on them, they figure out what the wind speed is, and they sort themselves out and they turn themselves. Because some of the turbines are shielded by the one behind it, so the one behind it hasn't got as much wind, therefore it doesn't need to stop and turn itself. Each blade, so each revolution, so 1.5 revolutions of our blade is enough to power a standard house. That's a standard 4-bedroom house for a whole day. So that's quite a lot. So just 1.5 times that thing rotates around. That's a house for a day. The ones at Dogger Bank, I don't know if you guys were in the news, that was installed today. They are twice the size of ours. One revolution powers 2 houses for a day. So it's significant numbers. Cost us £1.5 billion to build our wind farm. So quite a lot of money. We are debt financed, so most of the wind farms that are built these days are either joint venture or debt financed. So they need this constant level of income to come in. The turbine, though, of that 1.6 billion, each turbine costs around £6 million for the turbine, and ours were built. Ours were made, so the blades were made in Hull. The foundation was made in or the metal structure was made in Belgium, but the turbine itself was made in Denmark by Siemens. Where are we? 27 kilometres offshore. We are straight out from Harwich. Our export cables come out the top of the wind farm and trundle up towards Sizewell. When we built it, we had our construction centre in Lowestoft. Our turbines were assembled in Great Yarmouth. So basically what happens is we ship all our parts to Great Yarmouth in bits. Well, that turbine comes in lots of bits, lots of blades, and they build them up on the quayside in Great Yarmouth. They stand them on the vessel, and they take that vessel out and install 6 turbines at a time. And they take 24 hours to build a turbine. So just a bit around RWE as well. So it's not just about Galloper. We've got a whole array of wind farms around the UK ourselves. So all the green ones, you can't probably see them, replicate our operational wind farms. We're now working on Sophia, which is Dogger Bank. So those turbines are 15 megawatts, so twice the size of the ones we've got. Ours are, what are they, 180 metres to the tip. Sophia's are 280 to the tip. The ones we're now looking at, 5 estuaries, North Falls, which are the extension projects to Galloper, we're looking at 400 metre to the tip turbines, so 20 megawatt turbines. And also down at Rampion as well, so on the south coast. So Rampion is there already, so Rampion 1 off the coast of Brighton. We're looking at Rampion 2, which is an extension which is going to be south and west of Rampion, and that will be similar size turbines, so 300 metre, 350 metre turbines. So you can see the advancement, the growth, the size, the scale has just grown massively over the last 10 years. So yeah, the one we're now working on, Sophia, the one we've just built was Triton Knoll. So yeah, we're constantly building around the UK. We expect to invest around 15 billion pounds in the UK by 2030, and that's just RWE. You've got the big players like Orsted and Vat and Fowler, all the other guys that are also pumping that money into the UK. So lots of money. So it's not just about the UK, so we've got all of these wind farms in the UK, but we also operate wind farms in Germany, in the Baltic, so we've got mainly here around Helgoland, are in Germany. We've got a couple of wind farms in Sweden and Denmark, but that's our operational fleet. So at the moment, RWE really focused on the UK and continental Europe. We are now expanding into APAC and America as well. So we've just won a number of auctions in America. America seems to be really galloping on the heels of the UK with regards to offshore wind. These are the ones that are in development. So we'll talk about the operational ones. So Rampion 2 for you guys. So Rampion 2 is on the south coast. Wellingmore is the Irish Sea. 5 estuaries, North Falls on the east coast. Dublin Array is going to be our first wind farm in Dublin. And you guys are talking about taking a photo and seeing wind farms behind it. There's a place in Dublin where everybody has their wedding photo taken. Our wind farm will be right behind it. It'd be lovely. just different. So we're building in Dogger Bank as well. So we're building Sophia at the moment. Dogger Bank South, which is just south of that, it's going to be twice the size again, so 3,000 megawatts. And then we've got a whole load in Germany and Denmark that we're also building at the moment. So Thor is our next one in Denmark that we're now starting to build. So you can see there's a huge amount going on, lots of offshore wind coming for the future. More importantly, you guys sail off the east coast. I've talked today about Galloper and Gabbard and the two extensions. These are all the other ones that are happening off the east coast. So these are not RWEs. And then you go over to sort of Belgium and Germany here. And I think I was talking about earlier on. There's this sort of wall of wind farms that you're going to have to sail through. But there may be a misconception. You can sail through them. There is no exclusions around them. So Gabbard, which was our first wind farm, when that was first built, the MMO gave us a 50-metre exclusion zone around every turbine. Galloper's come along, we've got no exclusion zone. So all wind farms that are built now, you can sail right up to them. It's a good thing for the fishermen, because if every one of these built, if all of these were built and every single turbine had an exclusion zone around it, we're wiping out a huge percentage of available fishing ground. So fishermen sail right up to our turbines. In some cases, they've got to put their red paint of their boat on my turbines. But yeah, they can sail right up to the turbines. But you can see mainly the sort of the east coast, there's a huge expansion. The blue ones are the ones that are in development. The green ones are operational, and the pink ones that are further out in those developments. These ones have just been put on hold by there's issues around commercial gain from those wind farms, so they're actually on hold at this moment in time. Might be somebody in the room that might know about those. So these are North Falls. So North Falls is this purple bit on the inside of Greater Gabbard, and that's where we're trying to extend. So these are just two extensions to the existing. So these two are the existing, and these are the two extensions. And we're looking to double what we've got. So double Gabbard into here, and double Galloper into 5 estuaries. One of the things, this is the traffic separation scheme that runs right through the middle of our wind farm. So we're clearly not allowed to build in there. And one of the things we're having to consider is lots of the shipping doesn't go through the traffic separation scheme. It comes around the top, and the natural shipping route is to cut this corner. So we're in discussions with lots of stakeholders around whether we can actually build this out here or not. Because if they have to, apparently it's going to cost them billions to go further around there, and maybe a compensation there. But fundamentally, that's what we're doing at the moment, is looking where we can possibly build our future wind farms. So what are the turbines? As I say, 6.3, tip height 180 metres. We've got 56 turbines. They're made by Siemens Energy. The blades are fiberglass. The structure is steel. The bit that you see on the top that everything connects to is called the nacelle. That's made of fiberglass as well. The older turbines are made of steel. Ours are made of fiberglass. It's a direct drive, so there's no gearbox, there's no big oil or anything in our turbine. These are they're quite latest design. They're a permanent magnet generator, so there's no exciter or anything in there. There's 90 magnets. So if you think about a normal generator that's got a north and a south pole, rotates at 3,000 RPM, these things rotate really slowly, but they've got multiple magnets in. Therefore, you don't need an exciter or anything else. You don't need a gearbox. Previously, Greater Gabbard wind farm, 3.6 megawatts, has got a massive gearbox in it that takes the low speed of the blades through a high-speed shaft through a gearbox into a generator. Latest design is you do away with all of that, and it makes them a lot more efficient, less maintenance. We only have to maintain these things once a year. So generally, we go out to the wind farm once a year to do maintenance, if they're in the run. So the monopile is this here. So I talked about this steel tube being hammered into the seabed, so that gets hammered in. This was called a transition piece. This is then plopped on the top and bolted on, so the monopile sits underneath this. And then, so that's bolted to the monopile, and then the tower, the white bit, is then bolted onto the top. So this has our boat landing, so the vessel comes along, trundles out to the wind farm. I call it a very expensive taxi to get my techs to work. Very expensive taxi. So they come along, this boat pushes on, there's rubber fender on the front of that boat. And as it pushes on the fender, it obviously does this. The rubber warms up and it just sticks. So the boat comes along, pushes full power basically, and it warms up, it sticks. And then the guys just step across and climb the ladder. There's a little bit more to it than that. There's a self-retracting line, so there's a safety line. So they come up, they grab the line, hook on, and then climb the ladder. The reason for that is if there's a rogue wave come, then that might not stick. So they're always hooked on as they do the transfer. It has been known on various different wind farms that this does let go every now and then. These boats capable of sticking to that turbine up to 1.7 metres significant wave height. So it has to be fairly rough for these things to fall off. And generally the technicians are being sick before we get there, before we want to transfer them. So yeah, they've got about a 90-minute journey from Harwich to the wind farm every morning at about 24 knots. So if on a rough day, it's not very nice by the time you get there. But yeah, really capable vessels. And we've got 3 of those at Galloper, so at the moment. Talk about this. There's the nacelle. So this is the nacelle. So that's got all the gubbins in it. So electrical converters, hydraulics, and all of these blades are pitched by hydraulic motors, and then electrical motors yaw the whole thing. So we've got 37 electrical motors that turn that thing round at the top. And all the equipment is lifted up through a little hatch under here. So when the guys go to maintain it, they climb up the monopile. There's a lift in here. So it takes about 3 minutes to get there in a lift. It takes about 40 minutes if the lift's broken. Because you've got to climb 100 metres on a ladder. And then when you get up there, they open this hatch, little crane comes down, picks the equipment up off the TP, and then they take it up and maintain the turbine. We originally had a helicopter at Galloper. After 2 years, we realised that actually the boats we use now are far more capable than we ever thought in the design. And the cost of the helicopter and the cost of the helipad, the cost of the training that we need to train our technicians just didn't outweigh or didn't sort of compensate for the availability of the boats have got better. So after 2 years we ditched the helicopter because we can get to them by boat, basically. If you imagine the size of the blade, 75 metres long, Airbus 380 is one blade. So these are all big kits. Out of the 75, ones that have been installed this week are 150 metres blades, and they're still made of fiberglass. So quite clever technology. The blades we've just installed at Kaskazi, which is similar to this but 9 megawatts, which is our German wind farm off Helgoland, are recyclable blades. So they're fiberglass, but they're made of so they're made so they're fully recyclable. The polymer that you use to stick things together, you basically dump it in a bath full of chemicals, and it dissolves all the resin, and then you can reuse the fiberglass once you take it off, which is all clever technology. Because one of the biggest things about offshore wind you've seen in the press of big fields in America where they're bulldozing fiberglass blades into a landfill, but yeah, they're very different at Kaskazi, these recyclable blades. Wake effect, I haven't got time for the video, but I will send you the presentation. But basically, imagine the wind going down this way. I've talked to somebody about which side you should sail from the turbine. This side, don't get them stuck in the other side. Basically, we've designed the wind farm so they're not in straight lines anymore. So you'll see London Array are in straight lines. Some of the later wind farms are designed so they're not in straight line. We look at the predominant wind direction. We understand where that's going to come from. But this is a new piece of technology that Siemens have come up with. These turbines are in straight lines, but they've got a piece of software that looks at the wind direction, looks at how much power this one is being starved by this one, and it will automatically yaw that one by 15 degrees. So basically the wind hits this and the wake goes over there and the same up. So it constantly looks at it and it moves the wake of the turbine out of the way so it's not impacting the next turbine. You get about 15 to 20% more power on the wind farm by just putting this bit of software on. There's a sweet spot because you imagine you've got your turbine again. You've got these fiberglass blades, and the wind is trying to push me, and then I'm trying to divert that wind over there. There's quite a lot of stress on the tower and stress on the blades. So there's a bit of a sweet spot on the angle that you can try and move that wind. Construction-wise, I talked about this was in Great Yarmouth, where we bring all these components singularly. We then put the towers, we then fit them out, and do as much work on shore as we possibly can, because it's not hugely safe offshore, and it's a lot safer to do it on terra firma. So we do all of that work on shore. We then pick that tower up and put it on this boat. So we've got 6 towers there. We've got all the blades are in this little rack here, you can see. So we've got enough for 6 turbines to be built. That vessel is around 300 metres long. I think that one was Pacific Orca. It's got jack-up legs. So basically it sails out, puts these legs on the seabed, lifts itself out. There's a stable platform and then uses this crane here to grab a hold of the equipment and put it on. We can build and commission a turbine in 24 hours. So that thing comes along, jacks up on the seabed, put the tower on, put the nacelle on, put the blades on, connect the cable, take the jack-up away, move it away, commission it, away you go to the next turbine. And that's only made possible by doing all of this onshore. This is the guys inside. So this particular turbine, I think there's about 136 bolts around here. M48, I think, so bolts. And they're basically got missing down as they go around. And this doesn't stop at night. We do this 24 hours a day. And we've got a very good crane operators from Siemens doing that. So it's not just about turbines. We have an offshore substation, 1,600 tonnes of substation. On there, 2 big transformers that take the power from 33,000 volts to 132,000 volts, and then take that to shore. So all the cables that come from the turbines are in these little tubes that go up here. So that inside these tubes are the cables, and the ones on the far side are the bigger ones that take the export out. But basically, we build this. I'll mention the after. We build this as a construction company, but as an operator, we're not allowed to operate the transmission network as well. There's a process in the UK that doesn't exist in any other country, where you have to have a second person that runs the transmission system, and that's called an offshore in the UK. So basically, you build it, you commission it, you then sell it to somebody else to operate for you for the next 25 years. So that takes the power from the turbines, steps it up to make it more efficient, sends it down those cables and connects it to Leicester. This is our cable vessel, so we pull 2 export cables in, we pull them one in one summer, one in the next summer. And basically this boat here, it's got a big carousel on here with the cable, so this is the cable, the stripy bit. It reverses as far as it can towards the sea. Then you have a little tug that takes a plough on the back, trundles it, dumps it on the beach. You then put the cable in it, and then you pull that boat basically pulls that plough and ploughs this cable into the seabed 2 meters deep. So all the way from the beach. Our cables were made by NKT, which are in North England. And we basically pulled them in over 2 summers because there's quite a long campaign for it. And it reduced the risk because offshore wind is really hippo weather. So my life is not about generation, my life's about logistics. When I can get a boat out there, when I get people out there, do I get the right tools? It's generally not about the generation side of the business. Yeah, that's it. Then we've got an onshore substation, that's what it looks like. Bearing in mind we want to look after the environment and visual impact, so we dug a big hole and all the spoil we create on the berm. So if you ever go to Sizewell Beach, hardly do, you'll never be able to see this because we sort of buried it in the environment. And we've got lots of equipment there that takes the power and cleans it all up. Offshore wind, the wind generated isn't particularly clean. It's got some harmonics associated with it. Got lots of filtration and capacitors and resistor banks, cleaning all the power up before it's connected to the national grid. And then, so basically in this building here is where it connects to the national grid, but all of the stuff outside is cleaning and filtering the electricity to make sure it's good enough to connect to the national grid. So fundamentally that's what it is. There's the monopile on, so Galloper North, Delta 1 Bravo. So if you see GN, that's our north field. We've got Galloper South. And GS is the one below the separation scheme. Each wind farm will have exactly the same thing. So if you're ever lost and you look at the numbers, hopefully you should be able to see where you are, as long as you know what the number means. And all of these point to, on the side of all our turbines, it tells you where the cables are. So on ours, if you sail up to it and you've got Alpha 1 Alpha to Bravo, Delta 1 Bravo, that means exactly where that line is, where the cable comes at the bottom and goes off to the other turbine. All the latest wind farms are doing that now. They never used to do it, but that's great for other people, fishermen and all that, know exactly where the cable's coming up the turbine.
It's buried though, isn't it?
It's buried 2 metres. And I'll show you later on. There's a bit of a problem with that. So this is
Oh, I like
a
it.
nice little picture. So we're monopiles. So we are relatively shallow water, say up to 50 metres. 50 metres to about 75 metres is jacket foundations. And then when I talk floating foundations on the far left, that's when you get really deep water. And you can't put that steel structure into the seabed. And that's a pretty good picture of everything. We've got an O&M base in Harwich, so state-of-the-art facility. I've got 60 odd people working in here. We've got pontoons, so purpose-built pontoon, 3 vessels. So the wind farm actually got built before this because of brown-bellied geese. Harwich has got so where we are positioned in Harwich, we've got a triple SI that side and an SPA that side. So we had to do lots of bird surveys. One of the reasons the helicopter was a problem is I couldn't have a helicopter at Harwich. I had to then use an airfield at Great Oakley because of, I forget what bird it was. It wasn't a bird. I can't remember what it was. But it's not just the wind farm that we have to worry about, the environment, it's the O&M base and everything else that goes associated with it. We've got 60 people working in this location. We're there for 23-year life. We employ lots of people. These are our apprentices in the first year. We've now had 7 or 8 apprentices go through the scheme at Harwich. This is our pontoon, our link span. We've got 80% of our employees live within an hour of Harwich or employed within an hour of Harwich. And like I say, we've got this massive apprenticeship scheme that we take people on as well. RWE takes on 18 apprentices every year across the whole of the UK, and that's only getting bigger. We can't get enough, basically. And we've got graduate schemes and all the other schemes that you'd expect us to have. Like I say, 90 minutes from Harwich on our boat. And this is a guy, he's got off here, he's basically climbed up. There's a self-retracting line there. So basically, as he gets to the front, he grabs the self-retracting line, hooks himself on, climbs up here, goes over here, climbs up, and then he gets to work. The vessels, these are catamarans, jet boats or CPP, 2 different types. Jet boats are more manoeuvrable, but tend to fall off the turbines a little bit easier. Propeller boats are less manoeuvrable, but actually once they're on, they seem to have a better stick onto that boat in front. Each one of these takes 12 technicians. We've just procured a boat at Galloper to take 24. So these are generally 24 metres by 8. The new best vessel it's in build at the moment in Isle of Wight. It's 27 metres long and 10 metres wide. So they're getting quite big, these boats. They're quite expensive. What do we do to the wind farm? I've got some more pictures of this in a minute. But we've got people hanging on blades. So we're in a harsh environment. So wind, rain, snow, ice, birds, everything else thrown at these blades, and they need lightning is our big issue. We've had a huge amount of lightning this year. So in the winter we can't get to it because of the wave height. In the summer we can't get to it because there's loads of lightning. So we always need people to go and repair them. We do all of our inspections via ROV, not ROV, by drone. So we can get around the wind farm in a week, basically. Every blade inspected within an inch of its life, photographed in the database, all remotely. Nobody goes on a blade. In basically a week we can do that. And then when we get those pictures back, we then look at them and go, what do we need to repair? And fundamentally we have to send somebody out on a rope to repair it. We haven't figured out how to repair them remotely yet. Just a picture of us doing some exercises. So every 3 months we have to do spill exercises, and we do casualty evacuation. So this stretcher has just come down from the hole at the back here. There isn't a person in there, no. That's a dummy in there. But you can imagine we're circa, some places in the wind farm, 2 hours away from medical care. So all of our technicians are, we call it Eureka trained, so they're all the highest training you can get below being a sort of paramedic. So they can all administer pain relief, all of that stuff, because we're a long way offshore. This is our own base, so we've got a 24-hour control room, so we do all the marine management. So should something happen in that wind farm in the middle of the night, we're all in there, and those guys will take charge of the situation, communicate with the harbour master, communicate with the Coast Guard, and manage those incidents. So there's always somebody there 24 hours a day. And I'm speeding up because I'm on that side. Just a few more pictures of some of the drills that we do. So this is on the offshore platform, man overboard stuff. This is inside the turbine, so you can't see it here. Basically inside the turbine, we have to get somebody on a stretcher, get them out of their area, and there's a hatch on the side. Send them out of the hatch, and then lower them down onto the TP, and then lower them off the TP onto the vessel, as we have done there. So they practice this every 3 months, and we do a drill every year with the RMLI. Some of the damage we've seen on the blade, so this was a lightning strike. That is the lightning receptor, so that worked really well, didn't it? In every blade there's a lightning receptor that's connected back to try and avoid this. But basically we've had a massive lightning strike there, and also here. So we'll have to go out there and do a repair on that. We generally have to get out there within 12 months, because basically if you leave, this is fiberglass with wood underneath. Basically, it's balsa wood underneath that fiberglass. So if you leave that for any length of time, it starts to rot the wood underneath. So it's really important to get out and do those repairs. And that repair looks like the bloke hanging on the rope here, grabs it down, fills it in, cleans it up. They've all got these little marks to say which blade they're on, who's done it, how many coatings they've put on it, and then paint it red when you finish, not leave it white. What else do we do? So this happened 2 weeks ago. So the generator, which is this bit here. So this bit in here, the circular bit behind. So this is the hub. The generator sits in here. We had a failure. So it's 5 years old. The generator failed. Basically, we've got a little grease in the generator. So we had to bring a vessel in to take it off. So this vessel comes in, jacks up beside the turbine, lifts the nacelle off the top, so just unbolts it. Drops it onto the deck, the vessel. They then take the hub off the front, then take the generator off and put it in here, refurbish the generator, and then reassemble back up again. So that was about 5 days' work, from legs in the seabed to back generating again.
The blades, were they taken off first?
Yeah, take the blades off first. So basically you can't see here. So you take the blades off. This is where the blades go on.
Yeah.
So you unbolt the blades and put them on this rack. Take the nacelle off, then disassemble it. And there's got this little hut on there because it has to be clean conditions when they're stripping that generator apart and putting it back together again. So they do break, but it's not. When you go and change a generator, I've worked in power stations. You have a problem with a generator on a power station, chuck a load of people at it, bring a lorry in. There's only a few of these in the world that will actually do it. So we've been waiting nearly 12 months for this. So that generator's been off for a while. Other problems, seabed. Talked about problems under the sea. So this is the turbine here. This is where the cable comes out. So the cable comes out. It's through this is like a plastic articulated cable protection system, and then it goes into a cast iron cable protection system, and it goes in the seabed and then it's buried. So just the end has got its protection system on. What we've noted over the last 5 years is there's current moves side to side. So this thing comes out and it's moving side to side, the seabed, and as it's moving side to side, it's rolling. So this thing rolls on the seabed and it rolls back the other way. And actually with the tide it goes backwards and forwards, and it does this all the way as well. So not only is it going from side to side with the tide, but it's just doing this all the time. And basically these cast iron things that hold it together, they're like little shells, they're falling apart. They're rolling over, and remember I talked about this rock being dumped around it? So this is rock under here. So this is the scour protection, and these things are rolling backwards and forwards over rock, and they've uncoupled themselves, and this is the exposed cable in here. So, so it's really, you first go down. We do first
tricky.
We look at this every year. So we send our ROVs down to check. We've gone down and gone,
Oh.
okay. So what we've had to do is design how we're going to stop it. So we've ended up putting a 4-ton rock bag either side of the cable, an 8-ton rock bag on the top, but you can't put it too close. Because if you put it too close, this then becomes a hinge. And it's going to snap there. So hundreds of engineering hours to figure out these two rock bags either sides to allow this far enough back to allow a little bit of movement, but not too much, to stop this unzipping completely, basically. Because if this unzips completely, the cable will just roll backwards and forwards on you can just about see it there, like the rock here. And that cable is only PVC cable wrapped in rope, and you'll see the rope has started, you can't see it on this photo, but the rope has started to come off, the sort of roving of that cable has started to come off. And we just finished this, so we ended up doing all 100 cable. So we've got 56 turbines, cables linked turbines to turbines, so we've had to go and put these rock bags down on all 100 locations. What else have we got a problem with? Mentioned about how deep cables are. This is monitoring a big sound wave that's running through our wind farm. So we do surveys every 2 years. So ROV, multi-beam, echo sound and side scan. Sonar. So this is a turbine. You can see where the scour is around the turbine. So the high spots and the low spots of that. But this is a sound wave that's running through the middle of our wind farm. And I think I've got on the next slide. Yeah. So this is the direction of movement. This is the height of the sound wave. So between the low spot and the high spot, so it's -4 metres plus 4. So we've got about 6 to 8 metre sound wave running through the wind farm. And we've buried our cables 2 metres deep. So
It's tough.
it's not an issue because the cables don't have to be buried. You just need to be careful where. So every year we do a survey. We update our charts for the fishermen so they know exactly where we've got exposed cable and when we haven't got exposed cable. So most of the wind farm it's all buried. We just have to update them every year of that where this is moving. It's moving very slowly. But we just have to update the charts every year just to make them aware of it. We didn't even know it's there. When we built the wind farm, it was outside of the wind farm, and now it's been coming through. This is just an image of how many vessels travel through a wind farm. So this is 2019. This is the north of the wind farm. And all of these little lines are vessels that have transitioned through our wind farm. So mostly fishermen. And interestingly, this is the south. So these are all vessels that have come round. And I've never worked out to this day why they all go through the north and never go through the south. But you rarely have anybody in the south of the wind farm. This is slightly shallower. So this is the shallower part of the sandbank. But we've got AIS tracking equipment that monitors every single boat that goes in every single minute within the wind farm. Unless you're a fisherman, you turn it off. Or a pirate. Because we have got, and they're not on the map, we have got a number of significant historic sites within the wind farm, and lots of wind farms have this. So, funny enough, it's a corridor where some of the warplanes and ships and everything that came back to the UK decided to dump stuff before they got back to the UK, and we found quite a lot. So when we build a wind farm, we do UXO surveys, and we will only intervene and move that UXO if it's within the area we're going to put a turbine. And sometimes we'll move our turbine because we don't want to deal with what's in the seabed. So there is a number of ordnance out there that we monitor, we keep an eye on it. Some we're moving through, they'll roll, so they will move, so we need to keep an eye on them. And there's a number of other historic sites throughout the wind farm that we have to keep an eye on. We do notice to mariners, so whenever we bring a boat in, so these are two of the boats we brought in, one for demobilising the OSP, this was the one for generator exchange. We always do a notice to mariner, that goes out 14 days before we're going to start the work. So you'll always have access to that. It's on the Kingfisher register as well. So whenever we have to do that work, we have to notify. I'm running late. So guano, big problem. I'm not going to talk about that. But yeah, so we have to send our guys to work. So everything needs to be cleaned. We have massive issues with guano off the east coast, as you can imagine. Habitat, so we do pre-construction, post-construction, benthic habitat surveys. So we look at the seabed, look at grain structure, look at everything on that seabed before we start. We then look at it once you've finished. You'll see in the words there, it changed slightly between pre and post-construction, but actually, was it due to the build of the wind farm? Was it seasonal? We didn't do the survey at the same time of the year at the end of it. But basically, you can see that we've done the construction that hasn't massively changed the benthic habitat. One of the things it does create is the monopiles being in there, we get these colonisation crustaceans, if you like to call them. But when we go down there, when we do the ROV surveys, thousands of starfish, God knows where they all come from. But yeah, we've got these habitats being built in the wind farms. The next biggest challenge the UK has with what was Bays, it's now, I've got the name of the company, or the name of the department, is when we come to decommission these. So the current thinking is everything out. So when we get to the end of our life, rip the cables up the seabed, pull the monopiles out, leave it as it was before we got there. But we're now thinking, is that the right thing to do? So you've built all of this habitat, why would you go and pull a cable out of, we've got something like 800 metres of cables within, 800 miles of cables within the wind farm, kilometres that we need to pull out. So why would you do that if you could just cut it off and leave it? On the flip side of that is, if every wind farm just cut off and left what's there, the seabed's going to be cluttered, isn't it? We also do bird surveys all the way through. So before construction, we had to check on our birds. So we do bird surveys, tagging. So this is to check that when we put the wind farm out, it hasn't changed what the birds fly into or don't fly into. The outcome of that is the wind farm hasn't impacted the lesser blackback gulls. The migration routes hadn't changed when we built the wind farm to when before it was built. We also track them on shore to see where they're going once they leave the wind farm and come on shore. We've finished that survey now and it's concluded that actually the wind farm has had very little impact on the birds. Aerial surveys, which birds, I know it's 8 o'clock and I'm just about done. One of the other things we're dealing with is special protection areas. So this is our wind farm here. This is an SPA on the east coast. We're not allowed to do major component replacement in November to March because we'll impact the red-throated divers, and we're not allowed to do sub-bottom profile and check the seabeds between October and March because of the harbour porpoise. So we're quite restrictive on what we can do below the water and above the water based on maintaining the environment. Lots of stuff on charities, so we've got charity funds. I'm a STEM ambassador as well, so I'm going to the schools and do lots of community engagement, litter picking, sponsoring bands, building ponds. That was a particularly dirty job. But lots of frogs. And like I say, STEM ambassadors, art projects, getting local schools in, colleges in to support offshore wind. And last slide, hopefully, that's where we were last year. That's the workforce in the UK, 31,000 people working offshore wind. That's where we need to be by the end of the decade. So we've got a massive challenge because the growth is huge. But we need to get there by the end of the decade. Apologies, I haven't left any time for questions. But I'm happy to take questions.
Thank you very much indeed, Sean. That was really interesting. We do have a few minutes for questions, if that's okay. I'm sure there's lots of...
Can I kick off?
Yeah.
On the presentation, you possibly answered it in the penultimate slide, but why are you quite so far away from the coast? Wouldn't it be easier to be about 10 kilometres offshore?
Best location for wind. So
the amount of wind, or just
it's the amount of wind and the depth of the water.
Yes. Okay.
Building on sandbanks. So we want to build it on a sandbank. We want to be far enough offshore to get the maximum amount of wind, so it's not impeded by the coastline.
Thank you. It's not just to stay clear of special groups. If that's the best.
No,
Thank you.
it's
where you can put them.
Where you can put them.
Thank you. Okay.
You had a question? Anne, you had a question? Anne? No? Okay, you have a question.
Thank you, great talk. With so many wind farms taking essentially so much energy out of the weather, does it have a measurable impact on the weather itself?
No. We've done lots of studies. Are we going to stop the wind in the world by putting the wind farms up? No. They do impact the next turbine and the next turbine, but very marginally. And the weather coming out of the back of the wind farm, it hasn't been able to measure the impact, but there's been lots of studies on it.
Nicola.
Hopefully not too technical a question, but it was news to me that you can have impurities in electricity, and you mentioned harmonics. If you might say something. So basically, when you make a AC waveform, so you make an AC waveform, so it goes positive and negative. So you've got 0 here, you create a waveform that does that. Basically, when you create it from a wind turbine, it's not smooth, it's got ripples in the waveform. And basically, if you put that into the national grid, it will screw up all of our electronic devices, basically. So basically, you've got to take all of those impurities out of the waveform out. And we use filters to do that. So we use resistors and capacitors to charge at different points. So basically, it tricks the line. It charges and discharges on that point to smooth that waveform out. So when it comes out of there, it's perfectly smooth. If you work in a power station, a generator in a power station runs at 3,000 revs per minute, and that is 50 cycles per second. So you can regulate it. It's perfectly run. These things are the speeds all over the place. So the wind doesn't blow. Generators run at one speed, then a different speed. So to smooth all of that out, not only do you have to do that at the filter when it gets to the substation, but on the turbine itself, we use thyristors to fire to create the waveform. So it's sent to shore at 50 hertz. That's right.
Is that running at 50 hertz then?
So where it comes at the generator is 50
Ah.
hertz. So basically we take generated at AC, so you've got a generator
Yeah.
that creates the power at AC. You then put it through a AC to DC converter. You then put it back through a DC to AC converter just to get to 50 hertz because it's at various different speeds.
Yes.
So the power that's being created is AC, but it's at like 20 hertz, 30 hertz, 70 hertz.
Yeah.
So you take that, put it through a AC to DC, DC to AC, and then it comes out at 50 hertz. So
You lose a lot of energy though.
you lose about 7%.
That's not
Yeah.
so bad then. No. But it needs some electronics to do it.
It does,
Wow.
thyristors.
Your question.
Hi, yeah, thank you. I thought it was generally very interesting. For the need to obviously massively expand the energy production that we're seeing across, your predictions of where we'll be for wind production, who or what or when or how is driving storage capacity? Because I think one of the biggest sort of sticks that renewable energy is hit with is that the wind doesn't blow all the time.
Yep.
So unless this is going sort of shoulder to shoulder with storage capacity, you will always sort of fall foul of that criticism. Is there a sort of national plan to expand storage?
There's not a national plan because the government changes every 4 years, or can change every 4 years.
Yes.
So there isn't a national plan. However, when we do the auction, we have these auctions every year to get funding.
Yeah.
This particular auction number 5, there's just no offshore wind.
Yeah.
It was all solar and storage. So they are getting incentives to build storage. It is around the cost. It's around the technology. Do we understand it? And at the moment, it's just lots of small batteries bottled together. Is battery storage the way to go? Lots of people are looking at chemical storage. So lots of people are now looking at creating offshore wind, so building offshore wind, creating hydrogen offshore, making the hydrogen offshore and pumping that to shore because you can store hydrogen. Unfortunately, the only way to store electricity is in batteries at the moment. Whereas, why not make it into a medium that you can store, ship it to, and then store it? Because it's easier, you have less losses as well from hydrogen. You have losses from shipping electricity to shore. To answer your question, there's no joined up plan. Lots of the big operators are looking at options for storage. I'm not sure big batteries is the way to go, but that's my personal view. I think we need to look at more innovative ways of storing something that we can then make back into electricity again.
Well, surely the problem's only going to become exacerbated as output increases from wind. So, yeah.
I'm hoping that the government, somebody else, there's a push for electrified transport. There's all of these cars sitting there that can support this storage. So if everybody connected their car, their bus, their everything to the network, you've got an answer there. You can use that storage for your network. That's not joined up.
Yes, true.
Lee, you had a question.
Yeah, thanks. Thanks very much. Very, very, very interesting. So these things are getting really tall, and I think you mentioned one that's 280 metres of sort of getting up to 900 feet tall. Presumably, my understanding kind of wind is there's quite a difference compared to wind at sea level and 900 feet up in both speed and direction.
Yes.
I mean, so that's presumably becoming quite an issue. I mean, how do you deal with that?
So on ours, it's 100 metres up is better than 10. So a calibre, and that's what the studies look at, where we position them. So what's the position of the wind? What's the speed of the wind coming off the land, off neighbouring wind farms? And they look at what height that is. So I think we're limited at 20 megawatt machines. So at the moment, nobody's looking at anything bigger than that. So that's 380 metres to the tip. And we've now reached where we think is the maximum we can go, based on the difference in that wind shear.
Yeah. I mean, does the blade change its angle as it gains height?
It bends.
It bends massively as it changes height, and as it's under load, it bends quite significantly. I don't know the answer, but I can certainly find that.
Georgina, you have a question.
It's just one thing you mentioned about renewables, and I think that this is a problem with a lot of industries. They claim that things are recyclable, but you mentioned a chemical bath.
Mhm.
How renewable is that chemical element, and how is that recyclable and environmentally disposable?
I don't know the answer. All I know is that they're
Because I mean, the idea that it's renewable, but the
Yep.
chemical, say for the fashion industry, there's all of these renewable materials, and yet the chemical offwash for that is devastating.
Yeah.
And 10,000 times worse than the original cotton project.
all I'm saying is the blades have got 25-year life. So this operation of breaking that resin down back into its raw state happens every 25 years for each one of these blades. But I'm not sure what chemical they use.
I was just wondering, how many of these blades then are we looking at in 2030, maybe every 25 years?
So the plan is every blade now being installed should be recyclable.
But at what cost?
Yeah. Good question.
Any other questions? Yes, back there.
Don't know the answer.
I mean, you might have answered this with the amount of animal surveys you had to do, but in terms of consenting, are there any common hurdles that most wind farms come up against with DCS?
The volume of people making applications. Our biggest hurdle is people being able to. We send everything to the MMO, and they haven't got enough people to do this. So that's our biggest problem from wind farms is the volume of wind farms coming online, the volume of consenting. It takes between 7 and 9 years to get consent for a wind farm. And that's because the amount of data that's needed, the amount of data that somebody has to churn through.
So how does that balance up with the 25-year lifespan? Because that's quite a significant part of its lifespan. You have to start planning its replacement.
25 is from commercial operation. So the day it goes commercial operation, we've got 25 years. The development stage is 10 years before that. But it does. The consenting takes an awful long time for obvious reasons. But it's a lot of data.
I saw early on in the slides that there was, you said a carbon saving of 3.5 tonnes.
Yes.
Is that for the whole offshore per turbine?
So that's for my wind farms. Just for the 350. So that's for the 56 wind farms, 56 turbines ago.
So that seemed relatively low because if you think about the 747, it's about 70 tonnes of carbon just for a single flight across to New York. So effectively we're saying that per day you'd need approximately 1,000 turbines to subsidise a single flight to New York.
Yeah. Mine is a comparison between an offshore wind farm and a gas-fired power station. So we're basically displacing a gas-fired power station, and we save 3.5 tonnes of CO2.
So from an energy usage perspective, stopping a single flight to New York is the equivalent of an output of 1,000 turbines.
Of this size, yeah.
So is that per day or per hour or per week?
Per day.
Per day.
Per day.
How much damage can a boat do to either explore pavement or
Depends how big the boat is.
Boats join into them.
We've had damage this year on one of our boat landings, and we found out which boat it was because it was red paint. We've got an AIS, so when you phone the company and go, "Have you been by a turbine?" No. Got your paint.
It's a good day at the races.
Got your paint, and your AIS was on, so you did crash it on. They're fairly robust, and the boat landing are bolted on anyway, so they won't impact the structural integrity of the turbine itself. And we've got sensors on the turbine, so not only at the top, but on the bottom of the turbine, we've got sensors on there that we see impact. And we won't, until we've done the investigation, got that data, analysed that data, the turbine stays off. One of the big problems we have in offshore wind is you're actually doing more damage by having the turbine off than running. So we get more stress on the turbine in idle mode than we do because they're designed to run all the time. So we actually have a limit of the life of the turbine, I forget how many hours it is, but it's measured in hours of how much time we can have it in idle. for the life. It's actually, these things sit constantly turning. So if you stop them, that's the worst thing you can do. Stop a turbine and leave it stopped. Even when it's in maintenance, you let it yaw into its natural position and just let the thing idle around. Unless you've got to work on the moving parts, then you stop it. Minimum amount of time in the stop position.
What's the maximum mast height that you could have?
So,
what's the bottom of?
So we've got 20. So I think ours are 26 meters above. Yeah.
So most boats, I think, manage to. You don't want to sail through, motor through. So.
If you're that close, you're a bit closer.
You have all these foundations effectively in the sea. Has there been any consideration about utilising those foundations, which are effectively doing nothing, to harness tidal energy, any kind of turbines that are going through in terms of, you've got a constant current going through there, so we've seen that kind of in certain offshore installations where they're utilising tidal movements, wave movements, tidal streams and so forth. It's extremely damaging, just the mechanical stress that's on those systems. But if you're able to attach those to those fixed foundations, there's potential that you could utilise and harness energy that way. Has there been thoughts around that?
So our latest wind farms that we're building in Germany, it's either Germany or Denmark, we are looking at stuff like that. So that we're having to look at the whole picture. Yeah. So wind farms with floating solar, with hydrogen, with alternative energy methods in the foundations. We're now being targeted to look at it. There's incentive schemes for us to do that. It's just the technology is not there yet.
Yeah.
And somebody's got to develop that technology. But the German government have got it right, I think. Whereas a certain percentage of a wind farm has to have these alternative solutions on in some of the continental Europe wind farms.
Really interesting discussion. I think we should continue that after dinner. It is now 8:15, and I think we ought to be moving on to our chicken supper. Please, let's thank Sean in the usual way. The number you use